All right, so this is the first lecture on inheritance. We are now taking a deep dive into object-oriented concepts, and by now you have a good idea of how classes work, what are constructors, and how to create objects in the client driver, and how to call methods and make the objects start to work for us. So here we are going to now explore the concept of inheritance, which is the relationship between classes. This relationship is a hierarchical relationship. So what this means is that if I have a class A and I have a ton of methods in class A, and so A is a useful class. It could be anything. It could be a graphics class. It could be a business related class. So we have an object already that can do a lot of stuff for us. And then what we'd like to do then is we would like to build enhancements on top of this class. Now we have the choice of either creating a class called enhancements, and let's call that E, and then copying all the methods of that class and making some changes to the behavior, to some of the behaviors. So making some changes and also maybe adding some behaviors. So when we'd like to do this kind of activity, then what we do not want is we do not want to have two big classes, A and E, where E is only a minor tweak on A. And in this case, what we can do is we can use the feature of inheritance in which we can create E and say E actually inherits from A. So we don't need to duplicate all of the code and make our programs extremely large. And also because A is a tried and tested method, and all of those methods are tested already, we know that if we import them or we inherit them into E, then we are going to be safe with regard to maintenance and debugging. And then the only things now we need to do is we need to either indicate the changes, the upgrades we need to make to some of the methods of A, and the new methods that we are going to add. So this is what inheritance does. It allows us to reuse code, and it allows us to build an is-a relationship. As we know that is-a relationship is a very normal relationship in nature where, for example, this could be an animal and this could be an elephant. So an elephant is an animal. So that's what this is. It's an is-a relationship. It's not the has-a relationship from object composition. And this is also represents a very natural, normal order, either in the plant kingdom, in the animal kingdom, and even in, for example, manufacturing activity. We could say here, this is a vehicle. And then we could say a vehicle could either be plane, or it could be a car, or it could be a boat, for example. So there's a lot of stuff in plane that that is common to a vehicle. For example, a vehicle has an engine. A vehicle has passengers. And a vehicle so it has seats and it has wheels. But as we know, the way the plane, the kind of engine that the plane has, the kind of wheels that it has, and the number of passengers that it can accommodate are different from a car, but the basic infrastructure is the same. So we would like to import the infrastructure. So this works for living and non-living things. So therefore, this is a very useful concept for us to explore. And Java is designed to be object-oriented programming. So here is the so here's what these are the main points regarding inheritance: code reuse, implicit copying, and new class only codes the difference. You can add a new method. For example, a plane can fly, a car cannot fly. Therefore, we cannot have a fly method in the vehicle because a vehicle implicitly talks about all the generic things that a vehicle can do. And then we say when plane inherits from vehicle, then we can add the fly method because a plane can fly. So, and and it can also redefine an inherited methods. What does this mean? This means in a vehicle, we can talk about carry passengers is a method. But when we talk about carry passengers in a plane, we can define the number of passengers to be 500, and passengers are going to be loaded into a plane using a a transportation system. And so the way the passengers embark and deplane is different from the way it happens in a car. So when we talk about passengers in a car, we're going to restrict it to between 4 and 8, and then we are going to talk about the passengers can just get into the car. They don't need additional transportation. So it alters the behavior. So just having passengers is done differently in a plane and differently in a car, and so that is redefining an existing method. Adding a new method is, for example, how is a plane and a car doing something different from a generic feature that's available in vehicle. So that's an example of that. Now, Java has single inheritance. So what does this mean? Now we're going to talk about, let's say this is our class A, and this is going to be our parent class or a superclass. So in our previous example, when we talked about a vehicle or animal, then this was the animal is going to be the superclass, and the elephant is going to be called the child class or derived class. In Java, you can only have one parent. So you cannot inherit from two parents or multiple parents. So that's what single inheritance means. Superclass, so the superclass is the parent class. There are multiple names for it. And I'm just going to use parent and superclass interchangeably, just because parent gives the hierarchical structure more naturally. And subclass is the child or the derived class, which is the elephant class. So here, what elephant is going to do is literally inherit all the genes, if you will, of the animal class, and it's going to also add some of its own new behaviors or change some of the parent behaviors. Now, what I'd like to do is I'd like to now go over some of the features with regard to how inside the machine parent and child class is connected, what do they look like, how do constructors function, and all of that. So here I've got a class called parent.java, and as you can see, all that the parent is doing is just has two variables, a, b, and then I've got these three constructors. One is a default constructor, here is the single variable constructor, and then there's a two variable constructor. And the child class has got a default constructor, it's got a two variable constructor, and it's got a toString method. And the main program, it simply creates a new child and then it prints the child. So just to go over the main program, the parent class is a regular class parent. This is the kind of classes that we've been creating so far. The child class, as you can see, is related to the parent class hierarchically, and it inherits from the parent class because we are using this keyword which says extends. So now Java knows that child class is an extension of the parent class, and the superclass is the parent and the child class is the child class. And then how do I create an object? Exactly in the same way as we have done before. So I can say child C is equal to new child. What happens when you do child C is equal to new child? What happens is that, I'm just going to go back to the PowerPoint just because I need a empty slide here. So what happens here is that we've got a parent class, and when this is the parent class, let's say. And now we say child C is equal to new child. What's happening here is that a child class is created, and I have deliberately chosen to make this bigger Because a child class contains in itself all of the methods and behaviors of the parent class. So the child object typically is at least as big as, if not bigger than, the parent class. And the constructor of the parent, the fields of the parent, and the methods of the parent are all going to be embedded inside the child class. And any additional method that the child class chooses to define are going to be here as part of the child class thing. And any redefined methods are also going to be here that belong to the child. So the child inherits everything, and Java automatically does this when it creates a child class. So this is what happens when I do child C is equal to new child. Now there are two concepts that one is of overriding, and the second thing is of adding, which we're going to explore a little more. Just to give you a heads up, that adding is when a child has new behaviors. For example, the parent has never traveled overseas before, but the child is going to travel overseas. So this is something new that's going to get added here, travel overseas. So know that this is not going to be part, this is only here in the child class. It's not part of the parent class. So this is a new behavior. What about overriding? Now overriding, let's say, eats method. A parent eats, but a parent likes to eat hamburgers. So there's an eat method in the parent in which the parent eats hamburgers only, but a child likes pizza and does not eat hamburgers. So the child is going to inherit the eat trait of the parent, eating hamburgers, but it's also going to have its own eat pizza method. And whenever you see a child eating, genetically, it has inherited the gene of eating hamburgers, but it's overridden that behavior with eating pizza. So if you see a child eating, then the child is only going to eat pizza. So that is the purpose of overriding. And if, for example, now the third thing is if we have a method in the parent which is playing games, and the game that the parent likes to play is, let's say, soccer, and the child is going to inherit play games soccer. And if the child does not add any new game to his or her repertoire, then what's going to happen is if you see a child playing a game, it's going to do it exactly the way the parent does it. It's going to play soccer. So if the child does not add any method or redefine any method, then then any other behavior is going to be exactly the same as the parent. So that's one thing to keep in mind. The other thing that I'd like to point out is the concept of constructor. The constructor is called into action and here's the default constructor because there's no parameters. The constructor is a method that's automatically called. Now, the constructor needs a special mention because the constructor is not inherited. Every other method is inherited, but the constructor is not inherited. However, when a child class is created, we know that whenever we create an object, the constructor is automatically called. If the child class has no constructor, the child class has no constructor, then automatically the default constructor of parent is called. Why is that? Because in any case, the child is going to inherit everything about the parent, and the parent has to be embedded inside the child. Therefore, the default constructor of the parent is going to get called. However, but no other, if the parent has multiple constructors, then the child does not inherit. Child does not inherit these constructors. The only time when the parent constructor of the is called automatically when you create the child class, if the child class has no constructor, then the default constructor of the parent is called. The minute you create a default constructor for the child, it's going to ask you, it will not then, if you have a default constructor created for the child, then it's not going to call the parent constructor, it's going to call the default constructor. I would like to explore the method calling mechanics in a little bit of detail a little later in this video, but for now, I'd just like to go over the constructor details, and then we'll go into how and what order methods are called when we create child objects. So here is a parent class, and the parent class has got three constructors: a default constructor, and then it's got a single variable constructor, and then it's got the double variable constructor. And the child class has got a single variable, a default constructor, and it's got a double variable constructor. First off, I'm going to comment any constructor by the child. So the child has no constructors. All that my child class has, it's got a toString method. And I'm going to create a child and just print. So because when the child is created, the parent is going to be embedded inside it, I want to know if my claim is true and the default constructor of the parent is called. So you see, now in my child, I had no constructor, but it was the parent class that had this default constructor. So it's evident to me here that the default constructor of the parent got called when I created this child and I printed it. Now let's go and not have a single variable constructor, but just have a default constructor for a child. And when I do that, it still did 9 and 6, even though here I had nothing. But as you have seen, I've used the keyword super here. So it's clear that when I created the child, now it's gone and called its own default constructor, in which I've used this strange keyword called super. Super is Java's way of forcing the child to call on its parent. So when you do super, you're calling the default constructor of the parent. And this is important for us to know. Let's say we did not use the word super. So when we did that, we called the default constructor of the parent, we got 9 and 6. Let's run it without the super. So as you can see, when we now in the default constructor of the child is getting called because we see that A is equal to 3 and B is equal to 44. When we call the parent, then we call the parent super constructor by calling super, then the values were what was set by the parent. It's interesting to see that if we don't do anything here, then you see the values are still the same as what the parent set it. And so the child has not done anything in its default constructor, but the parent constructor was called automatically because the parent is embedded inside the child, and therefore the values were what was set by the parent. So that's something for us to know. Now, another thing that I'd like to point out is that if in my main program, I try to create another child, let's say D is equal to new child 2 and 3, and here I have commented out the two variable constructor, thinking that, oh, the parent has a two variable constructor, so the child is going to, because it inherits everything, it's going to automatically call it. But let's see what happens here. You see, it says it cannot be applied. So I have an error here because no other constructor is, the constructors are not inherited by the child. If you'd like to specifically call the constructor of the parent, then we need to say that, mention super inside here. But if we don't do that, then it's not going to be able to, it doesn't have access to the parent constructor. The only thing that happens is that when the child class is created, the parent, automatically the default constructor of the parent is called. So no other constructor is going to get inherited by the child class. And when the child class creates its own default constructor, then that's the constructor that's going to get called. All right. So now here, as you can see, if I wanted the two variable constructor to get called, either I could have written my own A and B here, or I could have called the two variable constructor of the parent class, and that would work. So now what I'd like to do is I'd like to talk a little bit about overriding and overloading. I'd like to talk about overriding. So here I have an animal class, and here's my animal class constructor, and I have some methods for the animal: grow, get age, get name, get color. The one that we're going to focus on is sound method, and the toString method here. The animal in itself really should not be making any sounds, except that all animals need to have the capability to make a sound. So it's going to return nothing, because until we know which animal it is, we won't know what sound it's supposed to return. So let's go into the dog. Now, dog has its own constructor, but the dog method is a specific method because the dog makes a specific sound. And we know that dog inherits from animal, and dog is going to make the bow wow sound. And the toString method of the dog is, here this is the interesting thing. I have used the super keyword, but I've used it in a slightly different way than the constructor super, in that I've said super.toString. What does this mean? This means that call the animal's toString method here and add to that, append to those results, the breed as well. So we can completely do this. If you wish to call the method of the parent, then we can use super to force Java to call the method of the parent. And so here it's going to call the toString method of animal and then add to that breed. Let's go to tiger, and tiger is going to have its own sound, and it's going to be grr. But as you can see, tiger is not calling the animal sound method or using super. It's just going to just give this information. And let's look at the toString method of the animal. Let's make this a little more exciting and then maybe add sound here. and then, right? So we can actually call the sound method because it returns a string. So we can do this. So now let's go to the main program. And in our main program, we are creating some dogs and tigers and animals. And the first thing I'm doing here is printing the animal sound. We know that the animal has no sound, so this should not print anything. And now I should do println D1 and D2. If I don't add toString, Java automatically calls a toString method. So it's going to call the toString of dog. And here it's going to print the dog sound, and here it's going to print the tiger sound. So let's run this program and see what it does here. So you see the animal sound is printed nothing, but when it came to the dog, it's actually printed the breed of the dog, that's Labrador, and here it's printed the breed as Chihuahua. So these are the two dogs that we created, Buddy and Holly. The dog sound is bow wow and the tiger sound is grr. So what actually happened here? What happened here was I said D1.sound and T.sound. So when you did D1.sound, then let's go into the dog here, and it said, please call the sound method of the dog. Now, already there is a sound method that's inside the dog, which is this sound method that belongs to the animal. But what Java does is that when you call the sound method of the child class, it's going to look and see if the dog has got its own sound method. And if it has that, then this is the sound method that's going to get called. And so bow wow gets called. We don't get an empty one. If I were, so let me change the sound method to say, I do not have a sound. Then, and if for some reason I said I'm going to take away the sound method of the dog, then we know that it still has a sound, which is the animal sound. See, the dog sound, I do not have a sound. So if the dog sound has its own sound method, then that's the one that's going to get called. It's going to override or supersede the method that was inherited by it from animal, and it's going to do bow wow. But if the dog does not have its own behavior of sound, then it's going to fall back to its parent sound method, and it's going to say, I do not have a sound. So this kind of stuff is called mechanics of I'm just going to pull up the. So this is going to be so this is called the process of method dispatch. How does Java actually do the dispatch? So if you have a class B is equal to new B, in our case, let's say dog D is equal to new dog, then b.foo, when you call this method on the object, it looks in the class B first, its own class, to see if foo is defined there. And to extend the example of animal, if you do dog D is equal to new dog and you say D.sound, then it's going to look inside to see inside the dog to see if the sound method exists. If it does, it's going to execute that. If not, it looks in animal because dog extends animal and executes if it's there. So when whichever sound a foo method executes, whichever method it is, it's going to follow the same process. Look in the child. If it has it, execute that. If it doesn't have it, go back to the parent method and execute that. The only way you can break this rule is if you use the super keyword and then you force it to call the parent method. So now here, to call a different superclass, so this we have covered that. To call the superclass's overridden method, use super.method name. And this last feature of can't access super's private elements, this is an important feature. Just because a child inherits everything that belongs to the parent, does it mean that it has access to all of the parents' states? And that's an interesting thing for us to see. So let's say an animal has got age, name, and color. Let's go to the dog. The dog only has breed. Now, can we inside the animal, can we do something like system.out.println name? Can we do this is the question. It says the field animal.name is not visible. This means the child simply cannot dip into the wallet or do something that's private to the animal. It's going to have to, it can access it, but it needs to access it through the getters and setters. So for example, if it wants to get the parent name, then dog is going to have to do something like get name. So this is something for us to keep in mind. All right. Now let's go talk a little bit about the method dispatch. I'm going to so far we've only looked at what if F inherits from G, so single inheritance, but we can have a chain of inheritances like that. And then what's going to happen is, let's say we have the method, we have method 1 here, and we have method 2 here. When we call method 1 for F, and it doesn't find it in M2, it's going to call the parent M1 method, right? And here, for example, if I have, and the same thing for E. Let's say this has no methods. And then I create an object E is equal to new E, right? And then I say E.M1, it's going to go up the chain because now E inherits not just F, but because F has got G in it, it also has got everything that belongs to G. And therefore, if I do E.M1, it's going to look and see, do I have an M1? Does E have an M1? It does not have M1. It's going to go up the chain and look in F. F doesn't have M1 either, but then G has M1 and all of that still has gotten inherited by E, and therefore it's going to inherit, it's going to display the M1 method of G. This is important for us to know. And for example, here, if I redefine a method called M2 and I have age is equal to new age, and I do h.m2, then it's this one that's going to get called, not the one of F, which has got inherited by H. But if I say h.m1, then it's going to go all the way up the chain and go to G. However, if F had also got a method M1, then H is going to go up to F, and then it's going to execute the method of F, not the method of G. So it's important for us to know that we can traverse this chain up, and we'll just look at this example here. So here I've got these methods, G, F, H, and E, and G is the core method. It's got a two-string method that returns G, method 1 that returns G1, method 2 that returns G2. And then F extends G and it gives its own signature, but it does not have M1, it has method 2. But what it also does is not only does it print F2, but it also prints super.method2, which means it should also print the method of G. And now let's go to, so we've done G and F, now let's go to E, which extends F. And this again does not have M1, but it prints E2 and then it prints method 1. So whose method 1 is it going to print? It should print the method of F, but F does not have a method 1, so it's going to go back and print the method of G. And it does not, this one does not have its own two-string method. So if you say E.toString, then it doesn't have a two-string method, so it's going to have to print F. And lastly, we've got this H, which extends E, which is the bottom of the chain. It has method 1, but it does not have method 2. So I'm going to go to the main program and first create G and print method 1 and print method 2 of this object O and keep changing it. I'm going to go from G to F, F to H, and H to E, and then we'll see that the output is going to be completely different. So here it's going to be G, G1, G2, which made absolute sense because because G had a method 1 with, and that's what it printed, and a method 2, and that's what it printed, and then the two-string method also. So you see we've got 3. So this is how it's gone. So two-string method, method 1, give us space, and then print method 2. Let me change this to F because F inherits from G. And you see now, F has the two strings, so it's going to print F. F did not have a method 1, so it's going to print G1. And then this one is going to print its own method and the supers method. So that's what happened here. And then here, so we're done with F. Let's go to E. And then this is. You see, E did not have a two-string method, so it's going to print the supers one. E did not have a method 1, so it's printed that. It had its own method 2. It printed that, but now it did not have, E did not have a, what did E have? And it says print method 1, now after E2. But method 1 does not exist in F, so we had to go all the way to G. And now lastly, H. And this one. So H does not have its two strings, so it's used its parent two string. It had a method 1, but it did not have a method 2, and therefore it had to go to its parent 1, and then method 1, it printed its own method 1. So let's look at this last one, method 2 for H. It says print method 1, so it's going to print H1, but it did not have its own. Now this is very important for us to know. Now we are trying to print here method 2 for H. Method 2 for H does not exist, and H inherits from E. So it's going to print E2, which is done, and then call method 1. The question is right here, which method 1 is, are we going to go up the chain or down the chain? But at this point, Java is aware that the calling method is H1, and therefore it's going to look every single time there is a method call, it's going to look who is the caller and does it have its own method, and that's why it has printed H1, right? So I'm going to add this as an example in H1. and say that note that method that, actually I'll write this here in the main program, is that method dispatch always looks to see who is the calling object, right? No matter where we are in the chain, right? And then it calls the method and then it calls a method of that object. If the method does not exist, then it starts up the chain of the calling object. So that's an important thing to remember. All right, so I think we've covered most of the features. There are a couple other things about which are prelude to polymorphism, but I will do that in another video.